Hello everybody, welcome to this video about WAN Architecture. Thanks for tuning into this video. First I'd like to just apologize for the slight delay in producing this video and releasing it. It was supposed to be released yesterday, so apologize there for the slight delay. But I'm excited about this lesson and there's a lot to cover, so let's get into the lesson. What this lesson will be covering is there's 4 parts to this. So first we've got Metro Ethernet. We're going to be looking at Metro Ethernet and what I call the 3 sisters of Metro Ethernet. So we're looking at E-line and ELAN and E3. Then we'll be looking at MPLS, multi-protocol label switching. And then we'll be looking at GRE and IPsec and how they are actually better together when we combine them with a technology called GRE over IPsec. And then finally, site-to-site VPNs and remote access VPNs. We'll be comparing these two. So it's quite a lot to cover, so let's get into the lesson. So what exam topics are we actually covering? So if you look in the CCNA specification, the most recent specification, you'll see 1.0 network fundamentals. And in this section, 1.2 describe the characteristics of network topology architectures. 1.2d WAN, and in section 5 security fundamentals, it states describe IPsec remote access and site-to-site VPN. So we need to be able to describe network topology architecture characteristics and describing IP remote access and site-to-site VPNs. We need to be able to describe these. So this is where these topics I'm covering this video are coming from. Let's get into it. So firstly, part 1, we're going to look at Metro Ethernet. So what I call the 3 sisters, E-line, ELAN, E3, right? So if we take a look at this whiteboard, it just gives a brief overview of each of these technologies. So E-line service uses a point-to-point topology, and we have basically 2 CPEs exchanging frames as if they were sending over a really long crossover cable. So you can imagine a crossover cable, right? So the pairs are crossing over each other, hence the name. So pairs 1 and 3, you have, you have pair, so you have, if you look at a crossover cable, you have pin 3 to pin 1 on the other end, pin 2 to pin 6 on the other end. A giant crossover cable, right? Crossover cables we used to connect switches, right? So if you imagine a really long crossover cable from 2 CPEs, let's say one is in a branch office in West New York City and the other is in East New York City. You want to connect these 2 CPE devices. Well, if we use E-line, we are going to be sending as if we were sending over a giant crossover cable. That solution will be enabled by something called EVC, Ethernet Virtual Connection. Okay, but that's E-line there. Very brief overview. We'll be having I'll talk a bit more about E-line in an upcoming slide. Ethernet LAN service, ELAN, uses the full mesh topology, so different to E-line. Even though the name might E-line and ELAN. Sometimes I get my tongue twisted and I'm talking about E-line, but I just say E-line. But yeah, so the names are similar, but they are quite different. So point-to-point topology here, full mesh topology. You're connecting several sites using an any-to-any forwarding service. It's sort of like a giant switch. ELAN is. So okay, so this service is basically about acting as a LAN, so that all our devices can send frames to all other devices. Okay, all right, using an any-to-any forwarding service. Okay, very important to understand that term there, any-to-any forwarding service. Okay, so this ELAN service basically allows all devices connected to the service to send Ethernet frames directly to every other device, as if the Ethernet WAN service here is a giant switch. That's what I'm trying to say. So this device can send to this one, this device can send to router 2 or router 3 or router 4. Router 4 can send to router 1, can send to router 2, can send to router 3. You can have you can forward can forward Ethernet frames in any direction you want here. So, right, directly. E-tree uses different topologies. Okay, so we've got hub and spoke. You've got partial mesh or point to multi-point. So it uses different topologies, but basically, you have a central site communicating with a certain number of remote sites, but these remote sites, unlike ELAN, they can't communicate directly. So that's important to understand the differences between them. Okay, so here you just got two CPEs. You can send it either way. Here we've got several routers, okay, connected, and Ethernet frames can be sent either way. But here, central site has to send to the remote site. The remote site here, for example, this is New York, and that's and let's say that's Boston. They can't send it directly to each other. They have to go to through the central hub, which is in, let's say, Washington DC. So let's have a bit of a closer look at E-line. So it's also referred to as VPWS, Virtual Private Wire Service. Now, every E-line creates a point-to-point topology, right? Like I just said. So point-to-point topology, two CPEs exchanging Ethernet frames as if they're sending over a really long Ethernet cable. Here we've got, you can see, you've got one router here, one router here. Here, this is also E-line, but each one of these dashed lines is an E-line, separate E-line. So here we've got New York to Seattle, New York to Los Angeles, and New York to San Francisco. So we've got three E-lines. They're all separate E-lines. They all have separate subnets. One subnet is created for each E-line. Okay. Now, routing protocol and neighbor relationships occur between two routers on the E-line, but don't form on routers not connected to the E-line. So if I had a router here but it's not connected to that E-line, it's not going to be a routing protocol neighbor relationship being formed there. They need to be connected to the E-line. Like if I stick another router here for Las Vegas, for example, if it's not connected to an E-line, there is no router protocol neighbor relationship occurring. So let's move on, right? VPWS, so this term, as I mentioned, this is for another term for E-line. VPLS, Virtual Private LAN Service, another term for ELAN. Ethernet over MPLS, EO-MPLS is referring to transportation of layer 2 Ethernet frames over an an MPLS network. Now, here's some standards that I would like you to look at. Okay, so here are 6 standards that we should know about. 6 IEEE Ethernet standards, which are used for Metro Ethernet access, right? So, the first one, 100 base LX10. Now, 100 base refers to the speed here, 100 meg per second, 10 kilometers. This can do a distance of 10 kilometers. Okay, 1000 base LX. Okay, so we've stepped up now from 100 to 1000. So hence the speed's gone up to 1 gig per second. It could be up to 1 gig per second. However, it does half the distance of the predecessor here. That it could do 10 kilometers per second. 10 kilometers in distance. This is going to do 5. However, this big brother here, 1000 base LX10, can provide up to the same speed, 1 gig per second. Hence the name is here 1000. But this one can do 10 kilometers. So from 5 we go up to 10. So this one is in that sense superior to this one. Speed they both match, but this can do up to 10 kilometers in distance. 1000 base LX10, the bigger brother, I would call it, to 1000 base LX. Now, what's 1000 base ZX all about? Well, this also does speed of up to 1 gig per second. However, the distance goes up 10 times, up to 10 times more we can get. So this is just that's why I put an exclamation mark as well, because it's, wow, this is a jump here. 100 kilometers, no other standard compares. However, when we look at 10G base LR, and 10G refers to 10 gig per second, we're going up now. 10G base ER, we're going up as well here. 10 gig, both can provide up to 10 gig per second. However, in terms of distance, this can only do 10 kilometers, up to 10 kilometers, sorry. And this 10G base ER can do up to 40 kilometers. So it's very important to know these standards for the exam. Now, here's just a comparison with what we looked at in the last lesson about LAN architecture. So if you remember, these standards are created to like metaphorical people to represent each one, and these are the speeds. If you want to have a comparison, here you can look and compare those standards with them. So, but remember, these are used for Metro Ethernet access links. So it's important to make that association in your mind there. So so you might expect to see these being used as Ethernet access links because they support longer distance than standards that use UTP cabling, like in here. Excuse me. Now, I don't actually have a column to show the distance, but what you got to remember is these all, with the exception of this one, all 100 meters, up to 100 meters, whereas these you're looking at kilometers. So this tend to be used for UTP cabling. These tend to be used for Metro Ethernet access links. So, part 2, multi-protocol labeled switching. Okay, MPLS. So MPLS, what is it? It's a WAN service that is used to make packet forwarding decisions, right? So we have labels that are added between layer 2 and layer 3 headers. So this is why sometimes you might hear it as layer 2.5 protocol. But instead of how we typically forward packets, we check the destination IP address and routes of forward packets based on destination IP address in the packet. MPLS does not do that. It looks at the label and makes a much quicker decision by forwarding based on the label. So forwarding overhead is reduced, allowing for faster packet forwarding. Now, the MPLS WAN service comprises of several Ethernet enterprise sites with routers and switches, with an access link on each site. Access links can include various technology, including DSL, fiber, cable, 4G, and 5G. Now, so it's important to remember here, MPLS VPNs, they provide layer 3 service to the service provider's customers. Now, some people may refer to MPLS as a layer 2.5 protocol, like I said, but this is just because the MPLS header is inserted between layer 2 and layer 3 headers. Okay, there's no such thing as a layer 2.5 header. Okay, it's just like a colloquial term. Okay, but what is actually the point of MPLS VPN? What's actually the point of MPLS VPN? So I'm gonna now draw out on this whiteboard. I'm gonna draw out. We're gonna be using an example in my lesson of a school. In fact, not just one school, 4 schools. Okay, so we've got Buckingham Vale Federation. So this is 4 schools. Okay, this is just fictional schools in the UK. Okay, so that's where I'm from. So we've got 4 schools. Okay, so first one, second, third, and fourth. So the first school is in Cardiff, Wales. Okay, second is in London. The third is in so I'm going to say Cardiff, London, and Newcastle. I love Newcastle. Newcastle, and we need one more city in the UK. London, Cardiff, Newcastle. I'm going to add one more city. So we can have Glasgow, Scotland. So here we've got 4 schools in the, okay. So this belongs to this federation of schools. Now, these schools all have their own networks, but they need to communicate between each other. Now, MPLS can help us here, but what's the point of MPLS VPNs? Well, these schools will be using private IP address ranges, and they could all be using the same one. For example, the 192.168.0.0 range, very common to use that, especially in homes as well in the United States, and from what I've seen as well in the UK. So this IP addressing scheme could be used in all 4 sites. Now, MPLS needs to be able to route traffic without getting packets mixed up. We don't want MPLS sending packets that were destined for London going to Glasgow. So MPLS VPN enables a service provider to create one extensive MPLS network. This creates a private IP-based WAN, which keeps the IP routes separate for each customer. Okay, creating a private IP-based WAN, which keeps IP routes separate for each customer. Okay, routes kept separate for each customer. Now you might be thinking that MPLS VPNs encrypt data, right? Well, this is wrong. It's wrong. Okay. Now, when we think of VPNs, we do normally think encryption, but we've got to remember here, MPLS VPNs don't encrypt data to make it private. MPLS VPNs, they make our data private, but it's been by ensuring that data sent from one service provider customer, it's not sent to a different one. Okay, by creating a private IP-based WAN and keeping the IP routes separate for each customer. We don't send packets destined for Glasgow to Newcastle or London. So I want to ask you something. Do you know this? Routers discard an incoming data links frames header and trailer, and then when it's time to send a packet to a destination network, it builds a new data link header and trailer. Something very important to keep in mind. You might know this, that's great. It's just something to keep in mind. Now, MPLS support for data link protocols over various access links. So we've got to remember, routers discard an incoming data links frame, and discard an incoming data link frames header and trailer. When a router learns the outgoing interface, it builds a new data link header and trailer. Okay, so we've got a data link frame. Okay, you've got a header and a trailer. Okay, so those are discarded, okay, by a router. But when a router learns the outgoing interface for a new, when it learns the outgoing interface for another, when it comes to for routing to a destination, okay, it builds a new. Okay, so it builds, I'm going to try and draw a hammer here, but it builds a new header and trailer. So this means a packet can arrive on an interface using one layer 2 protocol, let's say token ring, and exit interface using another layer 2 protocol, I'll say frame relay, but so a packet can arrive on an interface using one layer 2 protocol and exit interface using another layer 2 protocol. Now let's look at CP and PE routers. Now CE routers do not become neighbors with each other. So these are CE routers here, customer edge routers. Okay, so these are the customer edge routers. Cardiff, we've got Newcastle, Glasgow, London. These are CE routers. They don't become neighbors with each other. Okay. The CE routers and the provider edge routers, the customer edge and the provider edge routers, they become neighbors with each other. And customer routes are advertised between the provider edge routers. So we've got 3 provider edge routers in this MPLS network here. And we've got 4 customers for each school. Now, so here we can see, just a closer look. You can see Cardiff's exchanging routes here with London and Glasgow. London's exchanging routes with Cardiff and Glasgow. Glasgow's exchanging routes with London and Cardiff, and Newcastle exchanging routes with Cardiff and London. So that's the advertising of routes within between the provider edge routers. Now let's look at GRE and IPsec. Now I say these are better together. Firstly, let's look at what security functions of a VPN are. And I want you to think of this acronym CADR. Stands for confidentiality, authentication, data integrity, and anti-replay. So confidentiality, preventing anyone other than the intended recipient from being able to read the data in the packet. Authentication, ensuring that the packet sender is legit. Data integrity, verifying nothing changed during the transit. Okay, and anti-replay, this prevents against repeat attacks. And repeat attacks can be quite dangerous, but anti-replay is something that helps against them. Sorry, that was quite a brief skim over this, but very important to know this. Okay, and KDOR will help you remember it. Okay, confidentiality, authentication, data integrity, and anti-replay. Now, generic routing encapsulation. This is something that's used for encapsulation. Okay, it encapsulates a wide variety of layer 3 protocols, broadcast and multicast messages. But for one of its downsides, that it doesn't provide encryption. It's not secure, but encapsulates a wide variety of layer 3 protocols, broadcast and multicast messages. Now, IPsec doesn't support multicast and broadcast traffic. So like GRE, it doesn't support that. However, what it can do, and what it does do, is it provides encryption. So what you can do is encryption, okay, and it's very commonly used for IPsec. It's very commonly used for site-to-site VPNs. Site-to-site VPNs. So you'll tend to see it used in site-to-site VPNs, S2S. I'm just abbreviating there, but unfortunately, though, because it doesn't support multicast broadcast traffic, ERGRP and OSPF can't be used on IPsec tunnels, but we've got something called GRE over IPsec, and this provides the best of both worlds. It helps overcome the limitations of GRE and IPsec, because when you combine these together, you get GRE over IPsec. I'm sorry, I know this is very cheesy, but what I'm trying to say is you get the best of both worlds here. You get the encapsulation, you get the support for layer 3 protocols. You get the support for broadcast and multicast traffic. Okay, so with GRE you get that broadcast multicast support. With IPsec you get encryption. Okay, you bring them together, and GRE over IPsec, it inherits qualities from both of these technologies here. So that's what makes it great. And just like how you got two parents and a child can inherit qualities from both parents, that's what I'm trying to say. GRE, IPsec, you bring them together to gain qualities of both. Now you can have support for ERGRP, for example, with GRE over IPsec, whereas before, with IPsec, you couldn't do that. Now, important points to be aware of. So I've said this a couple of times, but I just want to remind you, Layer 2.5 protocol, MPLS is referred to as a Layer 2.5 protocol, but there's no such thing as Layer 2.5 MPLS. Okay, GRE does not encapsulate data, encrypt data. Encrypt. It does not encrypt data. Sorry, that was a error in the slide. It does not encrypt data. Okay, IPsec does, but IPsec doesn't support broadcast and multicast. Okay, so it only supports unicast traffic. Okay, so OSPF and IGP can't be used over an IPsec tunnel, unfortunately. However, the limitation can be overcome with GRE over IPsec. And finally, dynamic multipoint VPN, DMVPN, is a Cisco solution. It helps us overcome the tedious effort required to set up a full mesh of tunnels. Okay, so with this technology can be done dynamically. Now, finally, site-to-site versus remote access VPNs. Now, site-to-site VPNs tend to use IPsec, as I was saying previously, and they're used to connect many devices at each site. Now, the IT department, for example, in our school, will have created a VPN connection, which is permanent support all users at the schools who need to use a VPN. Okay, so at each site that can connect many devices. So you can imagine a school, they'll have hundreds of PCs that need to connect to the internet, 100 PCs, and then tablets, and tablets, MacBooks. So there's many devices, and site-to-site VPN can support many devices at each site. Okay, it uses tunnel mode. Don't worry too much about this. I'll explain it on a whiteboard later. And there's no VPN client software needed. So you might see, for example, Cisco Secure Client, Forti Client. These client software is not needed for site-to-site VPNs. However, remote access VPNs are different. They typically use TLS, and they allow end-user devices to access corporate resources securely over the internet. So especially with like people who work from home, it's used, or students at, for example, at Buckingham Vale schools who are studying, who are currently doing homework at home, and they need to access the school's data center. Like for example, here I've got an example of a student called Janet, and she's got an iPad provided by a school. She uses a Cisco secure client. Here we have a TLS VPN tunnel connecting to the school data center that gives her secure access there. Okay, so that's an example of a remote access VPN. Okay, so we need to have a client, though, a client software installed. So for example, secure client. Okay, sorry, it's not secure connect, it's secure client, and that's used in this case. But you can different vendors have different have their own software. So Fortinet, for example, have FortiClient. Okay, now it uses transport mode, which I'm going to explain. So here you can just see up close, this is what secure client looks like installed on an iPad, and here you can see there is a connection to Buckingham Vale's VPN, currently not connected, but if Janet was to click that toggle there, would connect and should be connected to her school's remote access VPN. So let's finally look at tunnel mode and transport mode. So tunnel mode and transport mode, if you look here, essentially the difference between them, okay, you can see an IP header, you see a data, and you can see the data here, and you can see IPsec and an IP header there. What's happening is, with tunnel mode, which is we use for site-to-site VPNs, the IP header is encrypted. So the IP header is encrypted. However, with transport mode, which we use for remote access VPNs, the IP header is not encrypted. It's nowhere, you can't see anything. Okay, no encryption of IP header. So that's the main difference you just need to understand. Is that transport mode, there's no IP header encryption. With tunnel mode, there is, and just remember, tunnel mode is used for site-to-site VPNs, and remote access VPNs use transport mode. So a short quiz. Let's get into it. So firstly, question 1, what is another term for the ELAN service? So I'm going to give you 5 seconds to pause the video, have a think, and then play when you're ready. So 5, 4, 3, 2, 1, 0. So the answer is Virtual Private LAN Service, VPLS, okay? That's for ELAN, okay? Not Virtual Private Wire Service, that's for ELINE, okay? It's important to know the difference. Now, question 2, what does ELINE need in order for customer devices to communicate? 5, 4, 3, 2, 1, 0. So I hope you paused the video, had a chance to think, and then replay the video. So the answer is an Ethernet virtual connections. Okay, so that's EVC. Okay, EVC. Now, question number 3. What speed does 1000 base LX10 operate at? 5 seconds. Okay, 5, 4, 3, 2, 1, 0. So 1000 base LX10 operates at 1 gig per second. Okay, and that's indicated by 1000 base here. Okay. Now, question number 4. Which Metro Ethernet access offers support? Sorry, which Metro Ethernet access standard? Apologies there. Standard offers support. Supports the longest distance. Sorry, that question was worded really badly. Which Metro Ethernet access standard supports the longest distance? 5, 4, 3, 2, 1, 0. Okay, so the answer is 1000 base ZX. Okay, supports 100 kilometers. Question number 5. What is a point of presence? 5, 4, 3, 2, 1, 0. So a point of presence. Okay, that was a bit of a hard question. Sorry, I didn't mention that in the video. But point of presence is service providers installation of Ethernet switches as close as possible to a customer's site. Okay, and that's been done within the distance limitations of Ethernet fiber optic standards. Okay, so the switches are installed as close as possible to a customer's site. Finally, question number 6. So what does UNI stand for? Okay, what does UNI stand for? 5, 4, 3, 2, 1, 0. So UNI stands for User Network Interface. Okay, so sorry, that was not mentioned explicit. That wasn't mentioned in the video. So yeah, these two were a bit harder questions, but these are important to know. But don't worry, I'll mention them in an upcoming video. But thank you so much for watching this video. Hope you benefited from it. Sorry if I missed things out. There was a lot to cover, and unfortunately some things were left out. But hope this has given you an introduction to WAN architecture, and I really appreciate you taking the time to watch this video. So thank you so much for watching, and take care, guys, and I'll see you in another video. Thank you. Goodbye.